Alright, you've made it to the end. You've learned how to write these ridiculous long things like 1s2, 2s2, 2p6, etc., 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 all the way up to any element on the periodic table. Okay. It's time to show the shortcut because no one actually writes any of these the way they do. But if you don't understand the long way, then the shortcut doesn't make any sense. But we're going to do the shorthand electron configuration, which is also known as the noble gas configuration. So in our standard, this is this is the second bullet point. I can complete the shorthand configurations for elements 1 through 56. So honestly, by the end of this, you should be able to do all of them. It's not that hard. So, real quick. So first off, let's review our electron configuration. Remember, we have the orbitals, okay, so the s block and the p block and the d block, and the f block, and at the s we have the row numbers 1, 2, 3, 4, 5, 6, 7, and s is equal to n, and p is equal to n, and n minus 1 is d, and f is n minus 2. So it should make sense. Neon over here, it's in the second row, it's at the end of the p block, so it's going to end on 2p6 and 1s2, 2s2. Chlorine, next row down, it's in the p block, it's 5 spaces in, so it ends on 3p5, and we got all the rest of it. Argon is right next to it, so it's one higher, so obviously that's 3p6. And then you have iron, Fe, which is right there in the middle of the d block, so it actually is 3d6. Okay, the other piece you got to remember is this last row on the periodic table right here, helium, all of these guys. These are the noble gases. They're called noble gases because they don't like to react. They like to be by themselves. They're very, very stable. In fact, they're so stable they just kind of sit there. That's why we play with them. Helium is fun. But the noble gases are kind of our baseline. Okay. Everything in chemistry, unless it's nuclear chemistry, has to do with electrons. And so anything outside of what we call, all atoms want to be like a noble gas. And they actually do stuff to become like a noble gas. We're going to get into in future units. So the big thing is you understand is everybody wants to be like a noble gas. Well, how does that apply with electron configurations? How can that save us some time? Well, it works like this. Electron configuration shorthand. You use the noble gas that's located on the periodic table before the element. So basically you find the last noble gas. Okay, because like I said, noble gas configuration is stable. So anything, we only actually, once it's in noble gas configuration, or once it's like a noble gas, we don't care because it doesn't do anything. It's inert. We only care about the electrons that come after the last noble gas because they actually can do stuff. So you find it. Then you put the symbol of that noble gas in a bracket. Brackets is the little square thingamajiggers. Okay. Then you write the rest of the configuration after that. This is where knowing how to read a periodic table and how to know where an element is on the periodic table, what block it is, and what row number it is, the n number, makes your life way easier. Okay. So here's the example, fluorine, and this will make more sense when I show you the periodic table. We put the element that comes before it in brackets, and we put the rest of the electrons there. So here, let me show you. Here's our example. So neon. Neon, we already talked about. Neon is right here on the periodic table. Okay. So it ends in 2p6. Okay. The last noble gas before neon is helium right here. Helium ends on 1s2. So that means this part right here, all of this is the only stuff that makes neon different from helium. So we can shortcut it. We put a bracket and we put HE. In this case, the HE is just the 1s2. Then we write everything that's not HE. In this case, it would be 2s2, 2p6. Is this one particularly easier? Not really, but it'll start making more sense. So there's noble gas. We put the previous noble gas configuration. We put the previous noble gas in there. We put all the elements all the electrons that came after it. So let me show you chlorine. Okay. So chlorine's on the next row. So chlorine ends in it's in the third row, it's in the p block, and it's the fifth one over. So it's going to end in 3p5, which we have written right here. Okay, so that's that. The last noble gas is neon. So neon, remember, neon ends on 2p6. That means all of this stuff right here, this is all neon, and these are the 7 electrons that make chlorine different from neon. So let's save ourselves some time. Instead of writing out this big long one, we put a parentheses around it. We write the stuff that's neon, brackets I mean, and then we write the stuff that's not neon. In this case, the 3s2 3p5. See, like I said, if you understand how to read the table and you know this is the p block, this is the d block, all that kind of stuff, this is where it makes it easier to go back and do this. Okay, so next up, let me erase some here. We have argon. Argon is Ar. The previous element is neon, so it's going to be the same idea. Parentheses, neon, parentheses, 3s2, because we're going after neon, so we go to here, 3s2, and then all the way to argon, which is 3p6. Okay, it works really well. Let me show you the next one. Iron. Iron is right here. It's in the middle. So that's in the D block, right? So it's 6 spaces in the D block, so it ends on 3d6. So we go back on the periodic table. What's the last one? There's krypton. Boom, argon. Hey, look, argon came back. We're talking about argon. So argon, remember, ends on 3p6. So all of this right here, all of this is actually just argon. So I don't care about it. It's stable. These are the electrons that actually make iron interesting. So we can save ourselves some time when we write it like that. We put parentheses. We put the Ar. Argon ends on 3p6. So we don't have to write anything before 3p6. We just write what's left over. In this case, 4s2 3d6. That's the noble gas configuration, aka the shorthand, electron configuration shorthand. It works really well. Like if we want to do something ridiculous like, oh, I don't know, lead, which is right here. Lead ends in, it's in row 6, it's in the P block, so it ends in 6p2. The previous noble gas is xenon, so we'd put Xe, xenon, and we do everything after xenon. So then we go here, that's in row 6, so it's going to be 6s2, then it goes to there, which is the N, or the F block, so F minus 2 is 4f14, and then we're back up to the D block, and so it's going to be the D block, which is N minus 1, so 5d, and we go through all of it, 5d 10, and then finally we're in the P block 6p2. You may go like, oh wait, that's a lot, but then maybe you should go back and watch the mix where I did the regular shorthand or the regular electron configuration and watch me spend 3 minutes writing out lead. It takes a bit, so this is way faster. So let's do a couple more real quick. Calcium is right here. The previous noble gas is argon, so we put parentheses Ar, and the only thing that makes calcium unique is it's in the 1, 2, 3, 4th orbital, so 4s2. Boom, we are done. That's all you have to write for calcium. Okay, iodine. Iodine is right here, so we go back to the periodic table. The last one is krypton, so we put parentheses Kr, parentheses around it. So there's krypton. So we go here, so 1, 2, 3, 4, 5, so 5s2. And we go through this. We know this is the D sublevel. It's in so n minus 1, so 4d, and we know we go all the way to the end, so 4d10. Now we're back to our P block, so 5 and row number, so 5p, and then 1, 2, 3, 4, 5, 5p5. Okay, you start to see how this works. If you see how it works, you're welcome to stop. I'm not going to say anything else. I'll do one more example though for anyone who's still confused. So mercury is right here, so it's in the middle of the D block. It's in row 1, 2, 3, 4, 5, 6. So it's in row 6. So D is n minus 1. So it means it's 5d. It's almost at it's the very last one, so it's 5d10. So we know that's what we're ending on. We go back and we look at our table. So xenon is the previous noble gas, so parentheses Xe. When we go, we got 6s2. Oh, hey, look, we're down to the F block, so 4f14. And then we got down to the end, and then back up to the D blocks, and we knew that we were going to end on 5d10, so 5d10. There you go. Way faster. So you have to be able, though, to do the long way before you can do the short way. So don't bitch and moan to me about the fact like, oh, why did you teach us that first? That's so much easier. It's only easier if you understand the long way. So if you're having trouble with the long way, go back, get some more practice on this, on that, and then come back to this. Okay, good luck.